Welcome back. Got another example here for you guys. So first off, this looks very similar to our last example. Not our last example, 2 examples ago. So I'm going to go ahead and start off the usual approach. I'm going to identify my u. I want to identify that u is t squared, which, taking the derivative, gives me 2t dt. Never fear, variables are just variables. It could be any letter you want, as long as we remember that we do things with respect to specific variables. So I've taken the derivative with respect to t, giving me dt. I've taken the derivative with respect to u, giving me du. So in this case, dt be du over 2t. Okay. So looking at the integral here, t sine u, and I'm going to substitute my dt again, du over 2t. All right. I'll rewrite this over on the side. T sine of u du over 2t. All right. So I'm going to take a little bit of a less standard approach here. I'm going to throw some alternative techniques that I've seen to deal with canceling variables when it's not super obvious. Okay, so some of you guys might ask, what do I do here? Right, I have 2t in my denominator of my differential or my dx term. But I can't really cancel it out because I've got 2t here and I've got t. Well, what I can do is we can use some fun algebra tricks. And I'm going to go ahead and multiply t times 2. Let me get rid of this red bar. Multiply t times 2. All right. But if we remember, in algebra, everything has to be balanced, right? So if I have an arbitrary function here, a plus b over c. Okay. So let's say I want to cancel this c. This out. What I can do is I can multiply the inside, this here, by c, giving me c here in the numerator. But I don't want to change this expression because with what I've just done, I've completely changed the expression. But if I multiply by the reciprocal of c, that if I want to go back to the original statement, I can cancel my c's. So in this case, I've multiplied my inner part of my integrand by 2 so that I could cancel here. But I need to make sure that I didn't change the function. So I'm going to multiply the whole thing by 1/2. This is a sometimes more standard approach. I think it depends on how you learned. This is the same thing as just treating 2 as a constant and pulling it out of the integral entirely. So back to the integral here. I've got 1/2 integral sine of u du. Again, we know this. This is a standard trig integral here. 1/2. Oops. Negative cosine. The last step is just to substitute in. The last step is just to substitute in my u. I'm going to pull the negative out in front. Let's see.